I began talking about chapter 4 on Tuesday, and we have if we talk about if we are talking about equilibrium of rigid bodies, we are not because rigid bodies can rotate, right? So we have for a rigid body to stay at equilibrium, we need to have summation f equal to 0 and summation m equal to 0 as well. Now for 2D systems, we have summation f equal to 0. It means summation fx equal to 0 and summation fy equal to 0. That means the total force in the horizontal direction is equal to 0, and the total force in the vertical direction is also equal to 0. And because we have no rotation and the total moments, because in 2D system that everything is either going this way or this way, and so there is only one equation. So we have 3 equations and we have 3 unknowns. If we have only 3 unknowns, that we call it statically determinate. But if we have more than 3 unknowns, we call it statically indeterminate. Okay. Now that is what we discussed on Tuesday. Now we go to free body diagrams. I mentioned 3 key points in drawing free body diagrams. That the first one is contour. Contour is the shape of the free body, and the second thing is all external forces, including all external forces should be marked on the free body diagram. And the third thing is dimensions. Now let's for all external forces, this include reactions. Okay, it includes reactions, and all reactions, all supports. Include the supports, and all support reactions should also be included. Okay. For all these forces exerted by the supports, and we'll talk about here. We have 2 rules. The first rule, we have 2 rules. The first rule is if a support prevents the translation of body in a given direction, and force is developed on the body in that direction, prevents is I'm sorry. And for example, if when I put my cup on the on the desk, that it cannot fall, it cannot go downwards, right? So we have a reaction force going up, right? If I put it on my hand, that it cannot go down, so my hand has a force going up supporting the cup, right? So that one is the first thing. The second thing is if rotation is prevented, a moment is exerted on the body. So for example, because for a rigid body, it can go up and go down. So we have a force giving to the cup that it cannot go down, right? And the other thing is the cup itself can also rotate. because a cup is a rigid body, it can rotate, right? So if we want to fix it such that it cannot rotate, it means that we have a moment. If we put a moment onto the cup, that it cannot rotate either. So we have a moment acting on the support, so it cannot rotate. It is a reaction. This is a moment exerted by my hand, such that it cannot rotate. Okay, so let's go. These are two rules, but let's talk about some. Let's talk about some common examples. We go to the next page. Now, and in the coming, I think 3 or 4 weeks, that you will see many of this, and the important ones are number 1. Oh, sorry. Number 1, number 3, number 8, and number 10. Let me write it down. These are the most important one, and you should know them when you write your do a homework. Now, we have this. Let's talk about example 1. Here we have our free body, and we have a cable here. So it cannot move it cannot move away from the ground, right? It cannot, because we have a cable here, so we cannot move away from the ground. But this bar can move in this direction, right? It can move in this direction, and of course, because it is only a cable, that it can this one can rotate, right? Let me use another color. Let me write it. So it can rotate, right, and it can move in this direction, because this is only a cable. This is only a cable that this bar can move in this way, or it can rotate, but it cannot move away from. It cannot move away from the ground, right? So, according to rule 1, that means because we cannot the movement in this direction is prevented. So we have one force acting in this direction. Because we cannot move in this direction, it means we have one force going in this direction. So it's okay. Now, let's go to example 3. Example 3, we call this a roller support. This is a roller support. Now it means it has many rollers, or many round things down there, and this is we call it a hitch. Okay. It looks like this. Now we have a hinge and we have rollers. That means it is like a door here. It's like a door here. So we can move in. First of all we can rotate. We can rotate because it is a hinge, and it means we can rotate here. And because we have rollers here, we can move in this direction. And because this bar cannot go downwards, so we have it means we cannot go. The movement of these points cannot go downwards. Okay. In 2D system, we always think about whether it can move in X direction, Y direction, and whether we have rotation. We have three things to think about. Okay. We have three things to think about: whether it can move in X direction, Y direction, or can be rotate at this point. So in this case, we have we can move in this direction, and we can rotate in this direction, but we cannot move in this direction. So this will make one support force here. Now, is that okay? Let me go through all numbers 1, 3, 8, and 10, and then I will explain it again. Okay. Now we go to number 8. This one is a hinge, and sometimes if you see Chinese textbook, it's called this one or this one. Now we can in this string, we have only one hinge here, but it is fixed to the ground. In this case, we can move. This bar can rotate about this point, but can it move to the left or to the right? No. Okay. And can it move up or down? No. Okay. So it means these movement in these two directions are prevented. So we will have. It means we have two support forces. Okay. We have X in X direction and Y direction. And for the last one, let me make small. Is small. Now we come to number 10. In number 10, we have a totally fixed support like the length of or like what? Wait a minute. Like those electricity poles. Oops. Right, like those posts. Now, for this kind of fixed support, of course, for electricity pole, that it cannot move to the left or to the right. It cannot move up or down, right, and it cannot rotate either. So it means movement in this direction is prevented. Movement in this direction is prevented, and movement in rotation direction is also prevented. That means on drawing the forces, it means that we have all forces in both x and y directions, and we have a rotation moment as well. And it's okay. Now we have